Guys, today we're going to be exploring time series data, that is time series analysis. And before we start, we have to get our packages installed. We have to get T series, we have to get forecast, and then we have to be getting tidyverse. But today our studies will not be capturing the forecast, but this is very important for time series analysis too as well. So before we start, we have to load in our packages and continue with what we are doing. So you can simply just use command enter. So you just have to be on the line, just be on the code, and you can use command enter. Or better still, you can just highlight everything that you want to do, and you just use the run command here to execute everything for you. So with the run command, if I highlight a lot of packages and just highlight it and execute it once, it will just do everything for me with the highlight. But with my cursor on the line, that means I have to be executing it one by one in that order. So normally before we start time series, I normally tell my people to make use of the questions, the question mark on your RStudio. It's very important that if you don't know anything at all, you ask. And they have made room for these things in such a way that if you don't understand something, you can ask the machine, and the machine will actually tell you what it is all about. Now, if we want to generate some random values or random data and just use for our time series analysis, we are going to deal with AR and then what MA processes. So over here we can see that they're going to set C to 121. So you see set.seed. What does it mean? What does set.seed mean? And that means that what you should come here, then you can just highlight this line and execute. When you do that, at the help window here is telling you what that is all about. It's saying that random.seed is an integer vector containing the random generator state for random number generations in R. So this is just used to generate numbers in R. So when you use that command, you get to read a whole lot about what that command is all about. So if you don't understand, or if you don't understand the command, please use the question mark. Just add a question mark before that command and execute, and that the meaning of that command will be displayed on your help window over here. So now let's go ahead and set our C to 121, and we're going to generate AR an AR data. AR auto regression. AR is just auto-regressive data, right? And then that is what we're going to be doing here. So we just want to generate a list of numbers, and this is going to be our order. We're going to set the mean to 0.5 and our standard deviation to 0.01. That's an MA process. That's the order for an MA process. That's the order for an MA process. So you just highlight everything here and you are done. Now we want to stimulate it. We want to stimulate what we're doing here. So like I normally said, if you do not know something and you want to verify, there are rooms for that to happen. You don't know what is arima.what.sem. You don't know what this really means. The question mark is there to help you out. So once you are there, you just have to get that done, and it tells you a lot about that command. There is a lot here to let you understand. If you don't understand too, you go online, then you get to understand as well. So now over here we're going to stimulate our AR model or AR values that we just generated. So we do that, we get that done. And now the next thing here is just to view it. It's like you're going to, what they're just doing is just like generating numbers. You want to generate a number that you want to use for your analysis. So it's like generating number from 1 to 20, 1 to 30, 1 to 50, like random numbers. But our n here is set to 10,000, means that we want the number of observations to be equal to 10,000 and all that. So you are done generating these values and you are done stimulating them. You can actually view it, get to know what you've done. You can actually view it. So in viewing it, you have the view command that you can get to just type view, then you put in that AR1 process, then you execute, and a pop-up window appears here with the entries that you've just done. These are the values you have generated randomly. This is the things that you just did over here. This is the generation that you just did over here randomly, and this is what you've done over here. And now with this, the AR1 is just like naming something. You are going to name the data you're coming to generate. So it doesn't mean that normally it's just going to be AR1. You can give it any name at all. that you want. So it doesn't mean that it's always going to be AR1. You can always give it any name at all of your choice and all that. Now I was saying here too, you see list 2 is there. You don't know what list is all about. List 2 is there. You don't know what it's all about. You can actually use that help command to help you do that. And now we're coming to also generate moving averages. That is the MA process. Now in your econometrics tutorials, you have been told that with the AR process, I think with the MA process, I think that one has to do with white noise, right? You forecast the the current variable based on what the past errors and all that. But when it comes to AR or the AI process, I think that one has to do with forecasting the values based on past data. You are doing it based on past data. Let me just get something here for you to understand what we are coming to do over here. Let me just get something here, a slide here for you to know what we are coming to do over here. So this is a univariate analysis. So sorry, with the MA process it's all about forecasting the variable, or forecasting the variable based on what past error terms or based on the white noise. But with the AI process, that one you forecast the variable based on what the past values, the past and current values. That's what happens with the AI process. That's what happens. Let me show you this one on this one over here. Yes. So we are going to predict a variable based on future values. It predicts future values based on what past values over here. We are predicting it based on past values. But with the MA process over here, what you're going to be doing is you're going to predict based on what the error term, based on the error term over here, based on the error term over here, based on the error term over here, based on the error term over here. So now let's come back to our analysis. And we are done for the AI process. What is left for us to do is to generate our MA process. What is just telling me that it's going to be showing what first 1,000 rows. So when you check over here, you can see that it's showing you first 1,000. So this is the 1 to 8th row out of what 1,000. So it's showing you the first 1,000 rows. But in actual sense, the rows you've done is 10,000. You just did 10,000, but it will show you what it's going to show you the first 1,000 rows. Now we are done with this. Let's just go ahead and generate our MA process that we are going to be generating over here. Let's just go ahead and stimulate it over here. And now you have also generated an MA process, and what you want to do is to do what to view that thing too. You can also view it, and that is the MA process that you just did. For that. You just generated this random variable yourself with one column. That's what you just did. And now with AMA models is more or less like boxing what AR and then MA models together. So you have AMA models, which is talking about autoregressive moving averages. We have ARIMA models, we talk about autoregressive integrated moving averages. Then you have what SARIMA models, we talk about seasonal autoregressive integrated moving averages. So this is how the AMA models is being set. This is the one here. I think one here is for the AR and the last one here is for the MA. Alright, and because we don't have any integrated, we don't have any differential amount, we'll put it 0. We'll put it 0 over here for the differencing. Alright, so now that is done, and what you're going to do is stimulate that one that you just generated. You're going to stimulate the AMA model like we did for the AR and then the MA. Now you are done. So what you can also do here is to view. You can actually view your AMA model, AR MA1. You can view that as well. So when you run that, it comes here too. That is what you have done. So now you can see cbind down here. You can see cbind down here. What that means is that you're going to be doing column bind. So column bind means that what you're going to box them by column. So you have first column, second column, third column. You're going to box them. We also have R bind, which is row bind. When you want to combine data based on rows, you have from 1 to 100 rows, and then maybe you have another 100 to 200 rows, but they are of the same talking about the same thing, then you just want to combine them together, then use what? The R-bind. But over here it's like we have three data sets. We have AR1, MA1, and then we have ARMA. They want to box them together. They are not the same, right? So it's good to use what? The C bind, that is the column bind, to get all these ones done properly for us. So we get this done, and now you can also view that. And when you view this, it's going to be an integrated, like a box of the three things you generated together. It's just going to be a box of those three. So now we have that one to done, and over here you can see that you have the AR1 process, MA1 process, and then the ARMA the ARMA1 process. Remember, the way you arrange your variables here, that's the way they will appear. So if I had brought MA first, MA comes first on the first column. If I had brought ARMA first, ARMA comes first as the first column. Now what are you going to do here? What I'm going to be doing here is just to plot it. What I'm doing here is just to plot what you just did, and you're going to set facets equals to a true. This facet command is going to just break it into three. So you have AR1, you have MA1, and you have ARMA mode. Those are three that you box them together. So we want to plot it such a way that it will separate this three data differently. So we are going to be sure the ARMA equals to true. That's a logical statement. The true, if you have done basics of what are, you know that we have logical statement where you have a true or false. So I'm setting this equals to true, and that means it's a logical statement. So we can just go ahead and execute that, and we are going to plot it to see. We just did that plot. So you can see that over here. Let me zoom it for you to get to understand what we're talking about. Over here you can see that we have this down here. So we have the AR1, that's the plot, MA1, that's the plot, and ARMA2, that's the plot. It has been able to facet them. It has been able to separate them into three for you, because you set the facet command here is equal to true. So if I had not brought that, you wouldn't be seeing that. So if I clean this facet equals to true, and I execute this, what do you get? Probably something like this. It doesn't even make sense. It's going to plot the AR1, the MA1, and the ARMA all in one, and it doesn't make sense. It doesn't make sense for you. It's very, very hard for you to read as a junior data analyst. It's very, very hard for you to read, but it has been able to do them very well, and it's able to give them a legend for you. So you have the red over here for AR1, this color here, and that color here for all of them too as well. So all I'll just do back is go back. Now we are done, and what we learned about is ACF, autocorrelation functions, right? ACF, just the correlation between a variable, like the lags of variables and all those things. So now you can just make an ACF plot. Now what you can do here first is just to plot your AR1. Remember, we have three data sets that you box them together. So what you can do is just to fix one of them out. Look at this one that we did over here. You can fix the AR1 plot over here, and just plot that one separately. That's what we're coming to do over here. So you plot that one separately, and you hit your run. Now what it's going to do is going to give you that's the ACF function here, and let's just take a plot of it to see how it's going to be looking. This is how it's going to be looking. So now let's go back and see. This is an ACF, and normally the autocorrelation function at lag 0, or the first lag, is normally 1. So it is not surprising to be seeing this lag being 1 over here, because the autocorrelation function for lag 0 or the first lag is normally 1, because you did the proof and you saw how the variance or the covariance is going to be dividing itself. Anytime you have YO dividing YO, normally you're going to be getting 1 over here. So now we can also do a partial autocorrelation function. Now with this, you can see that you have a geometric decay over here. The lags kind of fall step by step. It doesn't fall just once, it just falls step by step for you to do all that. And now you can see there is a geometric decay over here for you, and this tells you that this is an AR process, or this is an AR model. Now you can use the ACF function to do that. Is a partial autocorrelation function. Partial autocorrelation function, that is the PACF. And now you can run this and look at this over here. It's only the lag. It's only lag of 1, which is standing tall. So over here the highest is 0.5, because we don't even have any lag more than 0.5 when it comes to PACF. So the highest here is 0.5, and then the lag of 1 is just probably the one